Alright everybody, welcome to the video for lesson number 3 for the chapter number 4 on dilations and scaled figures and all that stuff. So in today's lesson we finally started talking about dilations and graphing them, and we started actually getting to some real geometry, not the whole construction thing, which I know some of us were getting a little bit annoyed with. So one of the things that we learned from class today was that when I dilate a figure, we're going to use multiplication to find the image. So for example, in this first question, it tells us to find the coordinates of this point, -3, 2, under a dilation centered at the origin, that's what the O is, with a scale factor of 3. So all we're really doing here is we're taking the coordinate of the point, and to find the image, we're going to multiply it by 3. So this image is going to become -9, 6. You don't have to show the intermediate step there. I'm just putting it here so that we see where the numbers come from. Now, the other thing that we talked about in class was to find the scale factor, we're actually going to use division. So when I'm finding the image, we multiply. So if I know the image and I want to work backwards to the original figure, I want to use the division. So scale factor we're going to call K, or R, whatever variable you want to use here. And I want to divide the ending image from the beginning image. Now notice I'm just using the x values here. It shouldn't matter which one you use. So if I divide 4 by 8, I get a scale factor of 1/2. Scale factor of 1/2 would have told me that this image got closer to the point of dilation, which I'm sure is probably the origin. Also, if this was a figure, the figure would get smaller. Let's take a look at an example here. Triangle bug. So if we graph the points, so 2, 1 is here. -4, +4 is here. And -5, +2 is here. So we have B, U, G, and we'll use straight edges here. And we can go through and make our triangle. Alright, so the next part says to state the coordinates of B prime, U prime, G prime after reflection of the x-axis. To reflect over the x-axis, remember we take the coordinate of any point, and to go over the x-axis, we're going to change the y value to its opposite sign. So that means B prime is going to become 2, -1. U prime is going to become -4, -4. And G prime is going to become -5, -2. So if I go through and flip that all, so I have 2, -1 is here, B prime. I have -4, -4, that's going to be U prime. And -5, -2, that's going to be G prime. Again, we'll just do some connecting here with a straight edge. Please use straight edges if possible. It doesn't even have to be a ruler. The side of a notebook or something like that would be just fine. Then it wants us to take this new triangle we just found and find a dilation of 2 with origin as the center of dilation. So to find B double prime, I'm just going to multiply the x and the y value of B prime by 2, so 4, -2. To find U double prime, I'm going to multiply U prime's values by 2, so -8, -8. And G double prime is going to be -10, -4. Yay, they all fit. So if I go through and graph those, I have 4, -2, so I'm here. I have -8, -8, so I'm way down here. And -10, -4, so I'm way down here. So I have B double prime, U double prime, and G double prime. I'll connect these also with a straight edge. I'll just use a different color here so it doesn't get in the way. And the blue triangle that I'm drawing right now is the ending image. That's what we want to find. Notice it got bigger. It moved further away from the origin. That's what we want to see. Let's keep going. Next question. This was actually a Regents question. You can tell because the typeface was a little bit different here. And there's something in this question that you should remember from Algebra 1, but we are going to review again in a future lesson or unit, actually. So it says triangle QRS is graphed, and it wants us to find triangle Q prime, R prime, S prime, the image after dilation with a scale factor of 3/2. Since this is larger than 1, I'm going to get something that gets bigger. So essentially what we want to do here is multiply each of these points by 1.5. It's going to make our picture bigger. Now, the funny thing is, you didn't actually have to graph the new triangle. It doesn't actually tell you to. It just asks us to use slopes to explain why the two segments are parallel to each other. Now, if we're not finding the segments, we just have to really be able to explain this. So what we can say is the corresponding sides of dilated figures are parallel to each other. So Q prime R prime is parallel to QR. You didn't actually have to do any math here. You just had to know that when you dilate something, the lines were parallel, like we talked about in lesson 1 and 2, and again in here in lesson 3. Okay. Number 5, last question. So we see, again, the typeface here is a little bit different. This was another one of those Regents questions. Good questions to put on tests and things like that, right? By process of elimination, we should be able to figure out the answer here. I noticed that the two shapes are different in size, so right away it's not rigid motions only. It's going to have one of these dilations, so for sure it can't be choice 1 or choice 2. Then we have to figure out, well, other than a dilation, what other transformation did we have to do to get from this small triangle and turn it a little bit to get to this bigger triangle? Notice A and A prime are turned, B and B prime are turned, and C and C prime are turned, all about the same amount. Turned is a fancy way of us saying rotated. So the answer here is going to be choice 4. Translation doesn't make sense because that would require us to have all of these sides kind of be pointing, or vertices all pointing in the same direction, which isn't really happening anymore. And that's it. All right, nice quick homework assignment. Hopefully that was easier than what we've been doing, and we're going to keep going here tomorrow with these dilations. All right, those of you that are watching these videos, thumbs up for you. Expect a quick quiz at some point this week, probably Wednesday, all right, on some of this dilation stuff.